Hi guys, welcome back to Enginerds YouTube channel. My name is Patricia Bermudez and I will be your host for today's video. And for today's video, we will be again using the ideal gas equation, but for this one, we will be focusing on Charles's law. So the problem states that a balloon of 1 meter diameter contains helium at 300 Kelvin. If the balloon was cooled to 280 Kelvin, what will be the new diameter of the balloon? So we know that Charles's law states that pressure is constant. And if we're gonna relate that to the ideal gas equation, PV is equals to nRT, we know that the number of moles is constant. We know that the universal gas constant is a constant and pressure is constant. So ang nagvavary lang ay yung volume and temperature. And we know that volume is directly proportional to temperature. So the change in volume is equal or directly proportional to the change in temperature. So if we're gonna relate like two situations like before and after, we know that V1 is equal to T1, and if you divide that by V2 and this one by T2, we know that they are directly proportional. So this is actually Charles's law. Okay? And from here, since the question is asking for the diameter, and we can't really direct T2 sa diameter, di ba? I actually made that mistake when I took this exam. What I did was, I did D1 over D2 is equals to T1 over T2, which is wrong. Kasi hindi naman ito yung Charles's law. Ang Charles's law natin is, um, it relates temperature to volume, and diameter is not volume, okay? Diameter is a measure of length, and it's not really volume. So how are we gonna relate volume to diameter? First, you have to assume that the balloon is spherical. So bilog siya. And the volume for sphere is 4 over 3 pi r cubed. But since it is problem, diameter and given, so we're gonna replace r with d over 2. And d is for the diameter. Kasi diameter mo divided by 2 is the radius of any circle. So from there, we can simplify the volume. So 4 over 3 pi, and then r cubed, we will replace that with d over 2, and then cube. And then itong cube na to, i-distribute natin siya sa d and sa 2. So 4 over 3 pi d cubed over 2 raised to 3 is 8. And from here, we can simplify. Kasi 4 divided by 4 is 1, and 8 divided by 4 is 2. So here, we can simplify that as d cubed pi d cubed over 3 times 2 is 6. Yan yung volume ng sphere natin in terms of diameter. So this one is equal to this. So V1 is actually pi, and then the D1, which is the diameter of the balloon when we're talking about the initial volume. So pi and then D1 cubed over 6. And then V2 is pi D2 cubed over 6. And from here, from this equation, ang kailangan nating maging subject ay yung V2. Kasi ang hinahanap sa atin ay D2. Okay? So we know that V1 over V2 is equals to T1 over T2, right? And if we're gonna take the reciprocal of both, we have V2 over V1 is equal to T2 over T1. And then, ilagay na lang natin siya here. If we multiply both sides by V1, then magiging, yung V2 na lang ang matitira sa one side. So, V2 is equals to V1 P2 over P1. And we know that our V1 is pi B1 r cube over 6. Tapos, yung P2 natin, which is, mamaya na lang natin substitute, and then P1 here. Okay? And yung V2 natin, we know that it is pi B2 cube over 6. And then we equate this one. You equate this into here kasi ito yung V2 and then ito yung equivalent niya. So pi B1 cube over 6 P2 over P1. And since ang hinahanap sa question is yung new diameter, which is D2, i-isolate natin siya sa one side. So, D2 cube is equal to pi D1 cube T1, T2, sorry, over, tas ito, yung 6, i-multiply natin siya here. So, ito, multiply natin siya. So, lagay natin yung 6 dito. Ito. Itong nasa denominator here, we transfer this into the numerator. Tas itong pi, ilalagay natin sa denominator. So, nandito yung pi, na transpose natin sa denominator. And then, yung 6 here, you just copy. And then, yung T1 natin. So, may makakancel, right? Makakancel yung 6 pi. Both. And now, since D1 ang hinahanap sa atin, D2 ang hinahanap sa atin, hindi naman D2 cube, we have to take the cube root of both sides of the equation. So, take the cube root of this one, as well as this one. So, makakancel yung exponent na 3 here. And D2 would be equal to square root of, na-cancel na to, so it's just D1 cube times D2 over D1. Like so. And now we just gotta substitute. And in this problem, convenient na kasi yung temperature natin is in Kelvin. But if, for example, the temperature is given in Celsius, you have to convert it into Kelvin first. Or for instance, if it's given in Fahrenheit, you have to convert it into Rankine first. Okay? So, ayan, we just substitute here. So, yung dito natin is equal to the cube root. Sorry, I forgot the 3 here. Cube root of, yung D1 natin is 1 meter. Raised to 3. And then yung T2 natin is 280 Kelvin over. Yung T1 natin ay is 300 Kelvin. So, you can see na makakancel yung Kelvin. And yung meter cube here, makakancel din siya kasi you will take the cube root. So, matitira ay meters. So, ang new diameter natin ay cube root of 1 times 280 divided by 300, which is equal to 0.9772648.059 meters. So, that is the new diameter of the balloon. And for example, ganitong problem ulit yung lumabas, pwede mo na siyang i-direct substitute dito. Ito kasi yung equation na nakuha natin that we have derived that you can use for other problems when you're talking about temperature and diameter. Yeah. So, this is our solution for the problem. Always be careful that na hindi kayo magre-relate ng properties like diameter or radius directly dun sa temperature or sa pressure kasi hindi naman yun yung component ng ideal gas law. It's always volume, pressure, and temperature. And I hope you don't make the same mistake as me when I took this exam na direct lang D, then D1 over D2 is equals to T1 over T2. Hindi siya like ganyan. So you always have to account for the volume of something. And you have to relate that sa temperature. So ganyan mag-solve ng problem. Like this one, it's tricky but you have to be careful. And that's our solution for the problem. Thank you for listening and stay tuned for the next one. Bye-bye.